Hi everyone. Alright, so I have another rant about, I guess, statistics, since I made that other video about how statistics are not inherently racist because they're just math, and math basically just is supposed to help expose the truth, because that's basically all it is. But it's sort of, in a way, always separated from reality, so it can cause misunderstandings and things. But it's super useful, and people need to realize that just because you have someone who gets paid a lot of money or runs a business or is a doctor or is very hard to convince of things doesn't mean that their understanding of things is trustworthy. A crazed homeless person might have a better understanding of statistics than your, than most people would like to believe or appreciate. But it's true. So when it comes to homeopathic medicine, for example, there's a lot of opinions, and a lot of people just hear about it and they think, so you're telling me that you take some kind of toxin, like poison, a heavy metal, something like that, and you somehow mix it in water, and then you keep diluting it and diluting it and diluting it until essentially there is nothing left except just water and a couple molecules of this toxin. And people take that and it somehow helps them. So they conclude, oh, this must be, a scam. This is just a way for people to make money, or these people are crazy. This doesn't make any sense. Well, first of all, when it comes to doing anything in science, you can't just say, well, I'm going to take my current understanding of science and I'm just going to apply those rules, nothing else. So if you're just going to take basic chemistry, well, let's see. We're just going to take the concept that you have water and one molecule of some toxin. I suppose you could argue that your proteins or something in your blood would come in contact with this toxin and become more aware of it. Now, if you have this toxin somewhere in your body already, there's a chance that there's a couple molecules here or there floating around in your body already. So even that argument wouldn't make a lot of sense. So someone might just conclude, well, basic chemistry says that this is nonsense. Okay, well, we're not just talking about basic chemistry per se. Nobody ever says something like that if they're doing real science. So this is where statistical testing comes in, because you basically have to say, it might work, but for reasons we don't understand. Now, if somebody just throws it out after hearing all that, and they don't even consider the fact, and this is just an idea, that perhaps water remembers things somehow, not chemically, but using some other form of physics, something that we don't understand about electrochemical situations. Maybe the shape of, molecules in the arrangement, in the likelihood of the arrangement of their atoms and how likely they are to react with other molecules actually relates to their previous chemical, makeups or something like that. And we just don't detect it because most of the experiments that we do when it comes to chemistry is just very explicit reactions. Like, okay, we're going to mix this base with this acid. Oh, of course they're going to completely react. But we're not necessarily testing what water does maybe to one protein, which is very similar to another protein. depending on what it's been mixed with in the past. And when the chemistry is not so explicitly obvious, basic chemistry wise, what's going to happen, do we really check what happens on things that from a basic chemistry standpoint are flat, have the same probability of happening? Can we test the difference in those probabilities and see if something different happens between that? And it might not be something that's easy to test. There might be other things going on that you can't just explicitly explain. And so that's been the way science has been as long as people can remember. We've been testing things like, electricity, and now it's like, people call it dark matter, and they don't even know if it exists. It's just some theoretical idea that explains some equations that we have. And that's why we have these other models which help test things from a different point of view, from a different perspective. And that's what statistics are. Statistics are basically this model that's built off kind of dice rolling. You roll one dice, or one die, whatever you want to call it. I guess it's singular, you'd say die. And you sort of assume that you have a uniform distribution of, the numbers 1 through 6 showing up. And it's an assumption. But when you have 2 die, then you start, getting closer towards this normal distribution. And of course, you got other distributions. You got Zipf's distribution. You got a whole bunch of distributions. And whenever you do some sort of test in real life, you have to sort of make this choice to assume, to guess, basically, that this distribution that you're thinking of, like Zipf's law or the normal distribution or something like that, is actually matching something that's in reality. So if you're thinking about, car crashes, or you're thinking about a manufacturing system, and you have a little mechanism that chops off pieces of metal, and every once in a while it can fail, maybe its failure rate, or how far it moves in that cutting action, might match this like normal distribution. And when it fails, it's past this like really, it's really on the edge of the distribution. So it's basically, you're stating that it's possible for it to happen, but it's very unlikely, or it's not probable to happen that often. So it happens 1 out of 20,000 times or something. And based on your tests, you build a distributive model like this, and it might look like a normal distribution, and it might not. But the way statistics works is it's backwards from that. So instead of you taking explicit data and then forming some sort of distribution based on your data, it's sort of doing the reverse. It's kind of taking your distribution that you think the way things work, and then you try to guess data based on that. So, and a double-blind test is when a doctor basically has a whole bunch of the real medicine and a whole bunch of the fake medicine, and he doesn't even know which one's which. They all have serial numbers written on them, and he can hand them both out prescribing to help people. And then you have this control group and this testing group that you don't really see. He doesn't really know which ones yet, which ones are the ones being tested, and which ones are the ones just getting water or whatever. And you eventually, after you get the results of who got healed and who didn't get healed, you can compare them, and then you try to look at the comparisons and see if they're random. Now, if we're just testing to see if a coin has a 50-50 chance of landing on a heads, you can toss the coin 1,000,000 times, and you're probably not going to get precisely 50-50 heads and tails. But here's where statistics comes in. If we're going to assume we're in, let's say, 99% of possible universes that could exist, or 99.9%. We could come up with a range of how many heads and how many tails should be tossed. And you might say, well, at least 1,000 of each, or at least 10,000 of each, and then the rest can be the other. So you can have, at least 10, if there's at least 10,000 heads, and all the rest, 990,000 are tails, we can expect to see that. And if it's outside of that range, something's weird. That coin can't be, fair. This can't be random. There's like a 0.001% chance that happened, is basically the statement. So that's how that's how they do their tests in physics, is when they're testing like the mass of a particle, and they say, oh, we tested it up to like sigma 6. Well, they're just talking about how many standard deviations. They're basically saying there's assuming that the mass of this particle is measured according to a normal distribution, which they're just assuming that. They don't absolutely know that. It's just it's just like the best base model they have. It's based on rolling die. So they're saying, assuming that this model, the chance of the mass that we have being incorrect is like 0.0000001% or something like that. So there's not just the chance that it's in that, there's not, the things that are mismatching with reality are not just it's not just the fact that it's a very high percentage chance rather than absolute. That's not the only thing that mismatches statistics with reality. It's also the assumption of the model that they're using. So I'm not saying what they're doing is bad. I'm just pointing out that there's two kind of assumptions going on. One of them is what distribution you're using. And the other one is that you're saying, well, as long as it's more than 99% or more than 99.9%, then we're done. More than 99.99%, we'll say, then we're done. It's just deciding where to stop. It's deciding when to stop. So when they say sigma 6 or sigma 7 or something, those are getting super, super, super minuscule. And it's just how statistical math works. But it's a useful tool. And the reason why it's useful is because we don't know everything. That's the point. The point is you don't know what's really going on. The point is they don't have a good model. They don't know if it's multiverse. They don't know if it's this or that. They're just trying to detect the mass of this particle. So they use statistics to show, the mass. So when it comes to like testing whether a medicine works, you don't know how it works. It might not make any sense. It might be go up to this donkey and pet him 5 times instead of 6 times. Well, why would that make any sense? That's not the point. The point is this proves statistically if it works. That's all it is. So if you want to argue about whether homeopathic medicine works or doesn't work, don't try to point out how silly it is when it comes to there just being one molecule of some toxin in 8,000 gallons of water. Because your point that you're making is valid, but it's only valid in basic chemistry, and homeopathic medicine doesn't really claim anything about basic chemistry. The only thing they make claims about is that it somehow works, and that's it. So the only way to really prove it wrong is to do statistical double-blind tests, not to try to state that there's no explanation for how it works, because that's not the claim. Nobody claims to explain how it works. You can't prove something wrong by saying, well, I can't explain it, therefore it doesn't exist. Did they say that about gravity? Well, I don't know why gravity works, but I guess I just won't believe in it because I can't explain it. But you can test it. It's a law. So that's that's sort of how statistics works too, is it shows that something is not random. You don't know why. That's not the point. You just prove that it works. Or maybe you prove that it doesn't work. Maybe that it is always a scam. And just because and here's another thing about statistics. Just because people play off something and they make scams out of it, or because of its nature, it's more likely to be a scam, doesn't mean that it's a scam. In fact, that makes it even harder to deal with, because now you have people not knowing whether they're being scammed, and you have people trying to prove it right or wrong, and not knowing whether they're dealing with a scam when they're doing that. And you have people who believe in it, and they don't know if they're really even doing it correctly, and they essentially have the same effect as a scam. It's kind of like the business model of selling like Kirby vacuum cleaners or Cutco knives. They might be a legitimate, potentially sometimes overvalued product, depending on how much somebody pays for them. But at the same time, why wouldn't they survive in a Walmart? Is it just because they're not actually that valuable or economical? Or is it because that if you have a really expensive knife right next to a really cheap knife, even if it's more economical, people don't want to risk spending that kind of money, especially at Walmart, and they'll just buy the cheaper knife anyway. So, because the fact that those companies are constructed on a business model which goes door to door to sell to people, doesn't mean that just because as a result of that people will pay too much for those products, doesn't mean that those products are a scam. It's just an association. It's not necessarily a cause and effect. So I'm sure that the amount of scamminess involved with homeopathic medicine could be a lot higher than it is in other areas of medicine. But that doesn't prove that the base concept, the fundamental concept or ideas behind it are themselves an actual scam. So that's sort of my rant. Don't talk about it as a basic chemistry thing. Don't say, oh, well, obviously it's a scam because there's one molecule left and after they diluted it so much. Well, maybe water remembers something, and we don't really know how to test it, and you don't know either way whether it is true or not. But if you want to state something or complain about it, go get some money, go get some patients or whatever, and do a double-blind test where you write down, serial numbers, and then you split up randomly bottles into just regular water that you got from the tap and water that you diluted or whatever using the toxin or something, and make sure that you're working with someone who's had, results so they know how to do the dilution properly or something. And then do your test where you prescribe the medicine and you don't know whether you're handing them the real one or the fake one. And then at the very end, when you collect all the results, statistically prove that your results couldn't have been random. Once you look at all the serial numbers and match them up with the patients. That's how you do it. You don't just complain online and decide from no information whether something's just fake or not. You do an actual double-blind statistical test. And even statistics only go so far because, look what, the double slit experiment does. That's kind of weird. That's not... It's like the result of the experiment depends on whether it was observed by someone who's considered conscious or something like that. It's like, so are we all living in some kind of dream where reality is, you know, being projected from the mind of the dreamer. The statistics work in that type of situation? And then there's also the, you know, the idea of like that faith must be a vital component for the result to work sometimes, although they say that that's not necessary in homeopathy. So you also have to take those ideas into account too, because even statistics itself is just that. It's just statistics. And I'm saying to use it because people aren't even using it. But then even if you do use it 100% accurately and correctly, which hardly apparently anyone is doing, then you also have to realize its weaknesses and the fact that you're assuming a distribution and things like that. So that's my rant. You guys have a good day. See ya.